Hello, everyone. Um, here to give a recap of the just completed, concluded machine learning for teenagers. There's been on high demand about this, and I'll be sharing with you using the slide which I've worked on all of that. So, we termed the machine learning bootcamp, Build the Future, and all of that is run for 5 days. Um, so, welcome to the bootcamp. You're in the right place actually, and over the next 3 or 4 videos now, you will go from machine learning curious to building your own model from scratch. You don't need any coding experience actually, but it's good. But the series that you're going to be watching is going to be hands-on, real code, and real models. For myself, this is my name. I'm an hydrogeologist by background. I build things, and I'm also a very fast learner. I have my page from US Aberdeen. I lead CREED, which is the empowerment arm of the church, and also Startup Grind. I've built close to 7 or 8 projects now. Hydro agent, this is an agent that can read past literature and summarize them. LSTM forecast. I've also built a foundational model which is still under validation. And you can as well check my GitHub account, Show Outlier. And I just want to leave you with this: is the future get built by people who start now. Actually, future start from today, not actually start from tomorrow. Why does this bootcamp exist? AI is shaping the next decade from medicine to music. The people writing the rules now are mostly adults. I would think you should be in that room whether you're a teenager or adult. You don't need to wait. Model tools let you train models on the laptop. The barrier is not talent or money, it's exposure. We're based in Aberdeen, so local industry runs on AI, subsea, data set, energy, robotics. The skills you build, the skills you pick up here open real doors, actually, anywhere you go. So, what will happen 10 years' time, 2036, if we got tariffs? We're just making some few predictions. We're going to have AI co-scientists. AlphaFold have done that by Google DeepMind. They already cracked a 50-year-old biology problem. They are next helping inventing drugs, materials, and energy sources. There's tendency that we're going to have personalized medicine, treatment tuned to your DNA, your history, your lifestyle, not the average patient. There's tendency that people are going to be living longer, all of that. So we're going to have real-time translation, talk to anyone in any language, live, no app needed, already started with our earbuds today. Climate model that work, forecast extreme weather days earlier, that will optimize grid, farm, shipping in real time. We're going to have AI tutors for everyone, a patient, expert tutor in your pocket. Already happening, but just much more better by 26. We're going to have actually what I can call robot that's going to adapt. Today's robot do one job, but tomorrow's robot or in 10 years time will be able to learn new tasks and the way you would, and also be able to do on the job. These are prediction, not promises. Some will learn sooner, some later, and some not at all. You will help decide which actually. So what is machine learning? May I break it? Is machine learning. Let me go to this L first. The L shows the present continuous tense. So there's learning continuously, all of that. So just to make it simple, is to teach computers to learn from data. When you hear the word machine learning, the machine there is the computers, all of that. That's learning from data. Learning from data. Look into data, see pattern, see what is it, all of that. So when you hear the word machine learning, it's about teaching computer. Some can say guiding computer, teaching the computer to learn from data, and our own role is to be able to take decision for what is learned. Now let's just go to simple actual definition. So what's machine learning again? It's teaching computer to find patterns in data so that they can make decision without being told every rule. So in the olden times, instead of writing 1000 E for else rules or statement to tell a cat from a dog, we show the computer 10,000 photos, and the computer will see that, oh, this is different. I can group them, all of that. So the machine learning model learn from a lot of examples. Machine learning is not it's not going to be good with just two data sets or three data sets. It has to have a whole of the large data set, 1 million, 10,000, lot of data set. That's why it's going to be looking through to be able to see some patterns and learn from it. So traditional code versus machine learning. Traditional one, you give it the rules, data, you give it answers. You Android every rule, the computer just follow them. But machine learning is about you give it data, you give answers, and you get data and answers. You don't get the rules. You give the examples, the computer figure out the rule itself. That's what machine learning. So we have three types of machine learning: the supervised, which learn from label examples. We give the model the right answers during training, which is best for predicting things we already have data for, like spam and non-spam, those kind of emails we normally have. Unsupervised, this one find pattern on its own. No label is given. The model group similar things together, or spoil structure with miss. Like for instance, customer segment, type of customer, maybe customer that are under maybe lower than 18 or older than 18, or maybe old customer or young customer. The information learning is learning by trial and error. The model takes actions, get reward or penalties. If the model gets it right, it gets reward. If it does not get it through, maybe there's an error, penalties, and at the end of the day, we're able to learn strategy that wins, like a game playing AI. So let's look at examples. So have you talking about it? So what is supervised learning? Let me just break it to what we can see. For instance, if you go to your kitchen, you find that your some of the top of your tap is you see color red. When you see that like that, color red means that it's hot. When you see color blue, other one is mean cold. That is someone labeled those taps long ago. So you now when you so now if you want you if you want if without not opening the tap, if you want to predict what's going to happen before you touch the water, you know that, oh, anytime you see red, if you put your hand below it, it's going to give out water. So that's the work. That's how it works for machine learning. You put a label, and you put a label to an object, and you expect that, and by the time you are looking at that object over a time with the label, anytime you see the object again, you know the answer that's going to come. It's just like the same all of that. So when you see a red tap, what do you expect? Hot water. When you see a blue tap, what do you expect? Cold water. Because your mind has been there. That's where supervised work. But unsupervised, nobody told you anything. You doesn't have idea of the label. Like doesn't even know what blue means or green means. It's just like having a ball of 100 balls of different color, blue, red, and green, and mix them all together. The machine will just go there. It will separate the blue away from the green, from the also from the red. That's what we call clustering. The machine will sort them in all the mixed balls. Like for instance, if you have a set of a group of teenagers, boys and girls, for unsupervised, the machine learning will just separate them to two groups, boys and girls. And the machine learning can also look again. It can also separate them in terms of height, taller teenagers and shorter teenagers. The machine learning can also go again and group them in terms of their hairdo, all of that. The machine learning can go again, can sort them in terms of type of maybe people that use glasses or not. The machine learning can also spot the group them in terms of color of their shirt, people that carry bags, all of them. It's all about sorting them to groups. Now, reinforcement learning, you learn by missing. Your first golf, if you ever play golf, swing by missing the hole. And so the second. But every attempt tell you about something, you kept adjusting until the ball finally drops in. That is, you play golf until it goes in. Those are just give simple examples so that we can understand what it means. Again, this is the real meaning of this different types of machine learning. I'm just giving what I showed in the last slide in the way that you can understand it, how everyday life. Have you understand that there are different methods for these three different types of machine learning? We can use linear regression under supervised, which predicts a number from a straight line trend. We can use logistic regression, which predicts yes or no, spam or no spam. Decision trees, a flowchart of if or else split that learn that from data. Random forest, that is hundred of trees voting on the answer. Gradient boosting, which each tree fix the previous one's mistake. Neural network that think like us, uh, the cognitive stuff, the math behind images, speech, and language. We're not going to cover all of them during the boot camp. We didn't cover all of them. We only cover maybe two or all of them. So for method, machine learning method under unsupervised learning, K means clustering, that is split the data into K groups by similarity. The hierarchical clustering, build a tree of nested groups. The BS can find dense cluster, flag the odd ones out. PSA squeeze many column into useful few. TSNE and UMAP draws complex data on a flat 2D map. Anomaly detection, that is spot the example that does not belong. Again, not all of them will cover, but just give it like a broad overview of all of those stuff. What are the methods under reinforcement learning? Q learning, which learns the value of each action by trying it. Deep Q network, Q learning with neural network attached. Policy gradient, which learns the strategy directly, the values. Actor critic, one part act, the other grade the action. Multi-column method, we play a whole episode, then learn from the score. Exploit versus exploit, try something new or repeat what already works. Again, these are various types. But in the course of the bootcamp, we did not touch referral learning. They only work on supervised and unsupervised. I hope you have guys following. So how do you then know that a model is good? Which one we call evaluation metrics. We use the accuracy. We normally use that. So when we finish running the model, when we check them through the accuracy, just like when you want to check whether your food is good, what do you taste to check all of it. So these are you accuracy, share of all predictions that were correct, precision of four of the ones you flag, how many were right, recall of the ones that matters, how many it caught, F1 score, one number, balancing precision and recall, root mean square error, and I think mean absolute error, how far numeric predictions learn from the truth, R square, how much of the variation of the model explain, like if the R square is closer to one, that means that very good with all of that. If it's lower, you all know that basic maths. So machine learning is already in your pocket actually. If you TikTok, it's already decide you for your page. Spotify, it builds your Discover Weekly. Instagram, if you watch a particular page too much, too long, too often, or all of that, it's going to be showing that page and ranking for you. Google Map is able to predict traffic and ETAs. Chimes help you to generate the next one. Your bank is spot fraud on your card. Having said that, having given a recap on what machine learning all about, but the fuel that run machine learning is data. No good data, no good model. If you remember, we said machine learning is teaching computer to learn from data. So if there's no data for machine learning to learn from, there's actually no machine learning. So I'm going to just give you a brief. So that data is the fuel of machine learning. Without data, there's no machine learning. Having said that, the model is not smart on its own. It only know what data it has shown. So data can be text, data can be voice, as you are already be, data can be video, if you can see my face, data can be images, whether still or not still. That can be tweet on Twitter, maybe PDFs, a lot of PDF file that we never have. But the emphasis is that the more data we have usually beat a fancier model. Fancier model doesn't work, but the more data you have, able to give you evidence that this is right or wrong. 80% of any machine learning project is always data work. The first thing to check when things go wrong is your data. And we emphasize during the bootcamp, no data, no machine learning. Actually, the first thing you need to check when you are working on machine learning project is the data you are being given, the source, is it a primary data, secondary data, how genuine is data, which condition they carry, does it follow the ethics of data, this one we call FAIR, FAIRI, FAIRI, you can look through that. So data matters a lot. And now, there are two types of data actually, structured and unstructured. Structure is when you have them in columns like this, in live, in spreadsheet and database. They're very clean, easy to filter and sort. For instance, you have a song, you know the BPM and place. Track A, I want is the BPM 128, 12K. You see how it's in columns and rows. Very easy for, if you have a thousand of rows or columns, the machine will just look through and look at the patterns, separate them, or look at maybe you can predict and classify them. Unstructured, what we call raw data or messy. When we say something is messy, that's not organized, that is photos that you don't have, that you don't, like photos of animals that you don't know. You have to click look, look, all of those. Sometimes very messy videos, voice note, free text. But one of the peculiar things about I attended an event in London. We found that Messi data normally is very rich. It contains a lot of information, but actually you now need a lot of work to clean it before model can use it. Some examples of photos, voice note, tweet, like your voice can be high, can be low, can be all of that. It's not unstructured. All of that tweet, the PDF. So those are type all of that. And I think during the boot camp, we allowed teenagers to give an example. So I think as you are watching this video, I would like to ask you, what are the type, well, in your everyday life, what are the example of structured and unstructured? Everyday life, so you can do that as a personal classwork. Now, data normally have features and label, and what we know about each sample, the clue the model used to predict, and the label is what we want to predict, and the answer to the model is trying to learn. I'll come back again. So the features are the input of a data. What is the peculiarity about data? Like for instance, I'm a guy. What are my features? I mean, I don't have the features of a lady. I have features of what make me a man. So, but if anybody want to say what are the features of Sheol, Sheol like wearing cap, Sheol uses glasses, Sheol is very tall. All of what could be, who can predict? Like for instance, if anybody have not the way my features can predict the kind of cloth I'm going to wear, can predict the how, can predict whether I can jump up, can predict my height because of my height, can predict because of my stature, can predict how fast I can run. You can predict what want to, so the labels are always what want to predict, which like output, the answer the model is trying to learn. So now let's predict if a song is going to be hit. What are the features? The features are the one, the tempo, the energy, and the stability. And remember, for instance, if you are somebody that would like to listen to song that fast, 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 maybe all of that. So these are the features that you need to what make those features of that stuff. So how do I know it's it? For instance, yeah, if the tempo is high, energy is high, danceable, the ability is 0.7 is high, then the song is a hit. But when we have low tempo, low energy, low stability, it's low, and that is low. That's why sometimes all of us, I mean, please just change that song. All of that. But it's also peculiar to the kind of person because of what we say it to some people may actually be is subjective. But again, we just use it that, yeah. So I want to say that garbage machine is about garbage in, garbage out is what you data. What I'm sorry for saying, data is about garbage in, garbage out. Your data is what you put in, and your model, what you see about that data is what's going to work on and give you the result. I think I was right. So wrong labels. If your spam mails are labeled as not spam, the model learns the wrong thing. So if you label all your spam as not spam, and you now go to the model will just be seeing it as no spam, all of that. So that means that's what you give it, going to give us missing values, blank cells confuse most models. So I think what the machine learning might do is always work in all the cells. So if there's nothing there, if we just take anything else, so we have to decide either to drop or fill or input. So you don't leave any blank stuff. Bias samples, if your data only include one type of person or place, the model only works for them. So you see that the data you feed it is what the machine is going to work. That's why the data is actually the real work to do. What if there are cases where you don't have data, like places maybe part of the world, or when you don't have data or no data, you make some. How do you make some? You generate synthetic data. What is synthetic data? It's actually data generated to look and behave like the real thing. Use when real examples are scarce, private or expensive to collect. Like some of the healthcare data that are very difficult to get. Like some of the, you just synthesize them and you can use some of these AI tools. If you can describe prompt them very well, they can generate a lot of data that look like real life. Why does it matter? Real events stay real. Fraud, equipment failure, rare diseases, these are real things. Synthetic examples let a model see enough of them to learn the pattern. The catch, synthetic data also inherit the flaw of whatever is produced with. It's supplementary data, it never replaces them. So as you work on machine learning, don't depend so much on synthetic data because people also want to trace the source of that. But sometimes when you're doing research, when you do have, you can start with all of that. So let me walk through a very simple stuff which we did to. I don't know whether we did that during the stuff. Features of this song: tempo, energy, stability, loudness, duration, everything. The models will learn through all of this. That is, you must have supplied the song a lot of number of songs here. With the some of the song will have different tempo, different features. The model will go there, will look at thousands of past songs with their hit or flop labels, then learn which feature combinations matters. All of that. You're not able to predict whether this one is a hit through the probability. You can label it, or if you know based on what he has learned, and maybe what make a song to hit some past songs, maybe because of the maybe higher song relationship with all of this stuff. The higher some of them are the higher some of them so the energy you can link them together. All of them. I hope you guys are following me. Now, one of the things we've been saying that as you work on machine learning, right? Domain expertise is a key. Do you expertise that is? Are you sure your knowledge about, like, if you are in NHS or if you are in healthcare, and you have data about healthcare, there's no way the whatever result the machine learning give, you will be able to say, oh, is it right or wrong. But if you don't have the domain expertise, it will be difficult for you to be able to see the behavior of the result, all of that. Anyone can call model fit. The library is free, tutorial is 30 minutes long, fitting a model is helper, and they get easier every single year. Knowing the problem is rare. Understanding water, health, energy tells you which feature matters, which data is lying, and which result is too good to be true. So when you have domain expertise, you're able to know whether the result is good, accurate, because your domain expertise will help you as well. Creativity, finding the question. The best project starts with a question nobody thought to ask. Choosing the right problem beat optimizing the wrong one every time. So please, creativity. AI doesn't have creativity. All of that. AI can just machine learning can do all, but you are the one that will feed those things in based on your domain expertise. I want you to go and do this for yourself. Go to teachable google.com and open the site, image project, and do thumbs up, do some gestures, and capture it and see how the image will go. You are going to see your own features, your label, all of that. I won't have time to do that, but during the boot camp, the teenagers were able to do that by their group. So one of the tools that you're going to need throughout this bootcamp, Cloud Code, where you can generate the code. Nobody's learning how to code. Cell one, cell two, like one. Now Cloud Code can do that. All of that. There's no goal of doing a project if you cannot take it to the public. We normally call it ship it out. All of that. You normally ship it out in a GitHub. And why it matters, portfolio, they have a proof. People can see it, people can use it. And you can also track your own growth as well. And they have some of these features. I think I think as you follow these lessons, you're going to see how we ship what we're built. Machine learning is already actually working. People actually where can you work with machine learning? You can work with tech companies, you can work with healthcare, diagnosis, imaging, drug discovery and monitoring. You can work with energy industry, forecasting, maintenance, safety, subsist robotics. You can work with finance, fraud detection, credit risk, and pricing. You can work with science and research, climate, genomics, physics, technology, well, a lot of that. You can work in government and NGOs, disaster response, public health, and also policy. Reward. And we just want to add three case studies for you so that you can look at. Now, we have newborn baby in a place. Newborn, a lot of newborn, and you want to see how whether they are to detect to separate those born babies with some maybe ailment, all of that. What do? You collect a lot of record about past newborn baby, the audio recordings, breathing sound, audio newborn, asphyxiated newborn, a low cost microphone. You now label them, all of that. You train it on all of those stuff. The model will now learn to separate the healthy newborn with their belt, with their breath, and for the stress one. It will run on the phone, which matters where there's no data unit. There's some part of the country where they don't have that. So it would just alert if you now find that, if you now classify that, don't alert if the baby is healthy, but alert if the baby is at risk. So based on the what you have been trained it, because you're going to train with the healthy and non-healthy, so that by the time you see non-healthy, we just alert that we're able to get the lady out so that we can be of help. So that's another practical way of using machine learning, all of that. So making wind farm to grid work, grid ready. For instance, we collect a lot of this about uh the wind farm, which is data, wind speed, wind direction, air pressure, turbine output, weather forecast, historical curves. What the many that will be many wind farms, right? Not only one. So the model will go there, will go grid operator will have to be able to match supply and demand exactly, and too much will be too much energy is as much as too little. The model forecasts turbine output hours ahead so that the grid can plan. So what the models will do, we check all of these features of the all figures of wind farm for many farms as I put it there in their data, all of that. It will check some of those things and match their supply to their demand, all of that. It will have learned from that. From that. So what will be the impact? For you able to forecast the output, you able to forecast the hours ahead, and you able to live through labor that the the kind of energy at 2 o'clock, all of that. Be able to forecast because he has been trained all of this data, data set. He has able to match maybe when this one is high, it give more energy, or maybe when all of that. You will be able to look at those stuff, and this actually they have done it in real life stuff. Now, so I think in Haiti where we have earthquake and disaster, how do we do response? What you do, you collect data on seismic waveforms, tremor history, fault line maps, satellite imagery, ground information, video records of many earthquakes, many disasters. What did the model do? Model will learn because we are going to train the model on seismic record, peak out aftershock faster than any analysis could do. And satellite imagery map the worst hit block within hour. So we're able to look that. What are we going to get? Response that will be sent to people when something like that is coming. Maybe instead of everybody will just say alert on your phone that in 15 minutes time there's going to be earthquake of everybody going to know because in the machine learning I've learned from this. I've seen pattern patterns what happened, how it happened. So that's another way to do all of that. Yeah, as I run to a close, what are whatever we're going to teach you, we still want you to self-learn. Books worth your time, the 100-page machine learning book, Python crash course, hands-on machine learning, storytelling with data, weapons of math discussion, uh AI superpowers, all of that. So pick one, finish it, and then pick next. So yeah, videos that you can watch: free go camp. I watched that below. Three blue eyebrow, start quest, stitching machine, cargo leg where you can get it, and the energy on Coursera. So wrapping up, three things that you need to take home. Machine learning is learning from data. Instead of writing every rule, show computer example and learn valid patterns. Data has features and label, like the features are the input, labels are the output. Features are the clue that will give you the model. Labels are the answer I want you to learn. Machine learning is only part of our life. From TikTok to Google Maps, now you are learning how it actually works beneath. In the next video, uh, my colleague, Mr. Ayodeji, is going to take you through how do you open a real machine learning notebook in your browser, load the data set, look at the cleaning, train your first model, and all of those things you're going to learn. What you need to just bring, as I've done today, your laptop, notebook, and pen for sketchy ideas, curiosity, and questions from today. You just and a friend if they want to join you as you watch. So don't let them share with them already. So I don't know whether you have any question. Uh, Thank you so much.